Hi, I'm Holly Stower, Group Lead for Resources and Environment at Cleantech Group, and today I'll be talking about sustainability and critical materials. So what is a critical material? So a critical material are raw resources that are crucial for building the low carbon economy. So that is energy, ICT, communication and defense. Materials like, I think the main one you think about is lithium, but also cobalt, more unique rare earth magnets, things like neodymium, which is very fun to say. But these are all the essential building blocks of the low carbon economy. But the issue is that there is a severe supply and demand misalignment. The other reason that they are a critical material is that there is significant geographic concentration of a lot of these materials. So for example, there is significant amounts of lithium resources in Chile, Argentina, but the whole of the world need these materials. So there's supply and demand constraints as well, whilst being critical for being able to scale a lot of these industries that we determine to be clean tech. We see innovation across the critical materials supply chain. So we'll start with exploration. A really interesting application that we're seeing is a lot of AI. So that is taking hundreds of years of historic data from a lot of these mining majors, applying meaning to it and interpreting it to be able to forward look, to be able to predict with a far greater accuracy of where these materials actually are. So then when mining, the typical exploration pathway means that less than 1% of exploration activities are successful. Applying AI with exploration can improve that significantly, reducing time, saving costs, and meaning we can find, map, and access a lot more of these materials. So there's one application in exploration. In the middle of the value chain, we have refining. So a key one is direct lithium extraction. Technologies from Summit Nanotech, Mangrove Lithium, they are taking a process that uses miles and miles of land, water, and time. So the way you traditionally refine lithium is via evaporitic ponds. So picture miles and miles of beautiful but toxic ponds where lithium is slowly being refined due to evaporation. So they're taking that process and shrinking it down to something that looks more like a shipping container. That is reducing CapEx, reducing OpEx, reducing the amount of pollution in these areas, as well as water, time, and emissions. So it's a completely transformative process. It means that we can get more out of less, save money, and increase time, so you reduce that supply-demand lag as well. The final piece of technology that I'll outline is at the far end of this value chain when we're talking about recycling and refining. We are seeing more and more investment into urban mining. So that is countries that are conscious that when EV batteries, a lot of these materials come to the end of their life, you can recycle them, refine them, and reuse them, and start to create these circular supply chains as well. So some of the main drivers creating a market for some of these technologies across the critical materials supply chain is generally high demand. There are improvement of ESG credentials, environmental, social performance of mining and mines. All of these technologies achieve these things, as well as the sort of end markets for a lot of these technologies are to reduce emissions. So if you can reduce the upstream emissions of these critical materials, you also reduce the downstream emissions of your entire electric vehicle or your wind turbine. So alongside the significant number of drivers for these technologies, there still remains a lot of challenges for getting these technologies to scale. A lot of this wouldn't have been possible about 5 years ago. So the whole mining industry has gone through such a transformation when it comes to innovation, but previously have seen underinvestment for innovation for 20 years. So in light of that, a lot of these innovators that are working with mining majors, one, the challenge is that that's pretty much a prerequisite. You have to partner with a mining major to be able to bring your technologies to market, to pilot it, to sandbox it, to then start to scale it. So that can be a challenge. In general, these majors move fairly slowly. The pure huge scale of these mines means that any minor adjustment, if there was a delay of a couple of days, that has knock-on effects that can cost millions, if not billions. So the risks that a lot of these majors are apprehensive towards are not unfounded, but it does make it challenging considering that it is a prerequisite to work within a partnership. I think with sustainability and critical materials, it's a really interesting market in that we are really talking about mining. And historically, that has been an industry that has been sort of pitted against climate change. But now you add the dynamics of the necessity for a lot of these critical materials. Not only do we need to make mining sustainable, but they are part of the solution. So what, I guess, in our world of innovation and investment, the way we see that playing out is typically environmentally leaning investors now looking at mining a lot more, looking at these innovators a lot more and seeing them part of the solution rather than part of the problem. So sustainability and critical materials will continue to be on our radar. It's a subject that we will deep dive, whether that's looking into different battery chemistries, mining, urban mining. So yeah, please get in touch if this is a topic that you're looking into. If you have a solution or if you're investing in this space, we'd love to speak to you.